I work in H2O innovation as part of Genesys, and into H2O innovation, there is a group of companies working hardly trying to provide specialty chemicals, components, and consumables. We have 3 laboratories. One of them is based in Manchester, more focused on the research of and development of chemicals. Another one in San Diego, in California. They work both on the development of chemicals and on membrane autopsies. And our lab, based in Spain, where I work, is the one giving the analytical service to our company and to customers. It is important to keep in mind that to analyze a system, of course, it's important between the membrane and the failure of the membrane, but there are any other ways to contribute from a lab to help to improve the performance of a system and the treatment of water. I have included here a diagram of a plant. And of course, the autopsy of the membrane will give the end of the failure, how it affects one of the most important components of the process. But in some cases, it is necessary also to analyze additional components. For example, it is important to optimize, in some cases, the pretreatment of the water, about disinfection, about the acetylene system, etc. That's something that can be done also in a lab. And also to characterize the water, not only the ions that are going to have scaling potential that, of course, we have to know when we are talking about desalination, but also the suspended matter when we'll reach the membrane, for sure will deposit, because membranes were developed just to retain salts. So whenever it is not removed during the pretreatment, will affect the membrane. And it's very important to have a very good identification, both about the composition, which is something that can be obtained, for example, by analyzing the cartridge filters, or at some point, the source of certain material or components in foulant, which could be obtained from SDI filters, because by doing analysis on the SDI pads that you may obtain in plant when you make the measurement, you can have very useful information about certain components that may reach finally the membranes. And also, of course, the size of the particles coming with the water to really understand if a filter is working properly or not. So there are many different analyses that can be done. Today, we are going to focus on the autopsies. Maybe if you want to learn more about what to do with the pretreatment, we could join a different live stream with Wally to talk about. So membrane autopsies will give the failure of the membrane. It is a very important tool to understand why membranes are not working properly, okay? After many autopsies, for us, the main causes of membrane failure are, here we are showing 3, but they are actually 2. One is that damage, and the other is fouling or foulant. Okay, damage can have 2 different sources, physical or chemical damage. So the autopsies will give the clue. It is the only tool to distinguish if we are having a bad salt rejection, if it's due to a physical or mechanical damage, or to a chemical damage related to oxidation, incompatible chemicals, etc. And the third one, which is actually the most important, because the highest percentage of the membranes we autopsy show foulant as the main cause of failure. As I said, is fouling, and it can be reversible if a suitable and effective cleaner is applied on time. To select a cleaner, it is basic and essential to have a very good identification of the foulant. Foulants have a composite nature. There are multi-components on it. So it is necessary to have information about all of them to really choose the best cleaner, because that will mean a better performance of the cleaning procedure. We have to keep in mind always that the final impact of the presence of foulant on membranes, it's an irreversible damage. So if a cleaning procedure is not applied on time, if we are not using an appropriate cleaner, at the end, that reversible problem that we have, which is foulant, will turn into irreversible. So the autopsy gives this clue. It says which is actually the problem and if it will be possible to recover the membrane performance or not by doing tests at the lab. I must say that along the years, I've been doing autopsies for almost 20 years already. We have observed an improvement in the knowledge of the people working at the plants. So the problems that we were facing during autopsies when we started to make them were more simple than nowadays. Now the studies we make at the lab are more complicated. It's more difficult to find a failure because we understand that there is a better performance of operators in plant. That's something very good for the market, and that means that there is already an experience in desalination, which is something very, very good. But in any case, we still have to face with problems. And there is where the membrane autopsy helps to identify the problem. Here we are showing a photograph of the mess we have sometimes in the lab with membranes, because we receive many membranes per year. And we are going to have just some points about the procedure very fast. And we are not going to really go into the technical details, but just to show you the main parts of this process. An autopsy involves many tests, analysis, inspection, etc. It's important to have at the end a global idea. In some cases, customers ask just for specific details, but it doesn't make sense. An autopsy has to be seen and considered as a global summary of results and data. So we always include an external inspection, internal inspection, and tests and analysis. External inspection is essential. I mentioned this because in some cases we receive membranes from all over the world, and customers ask to send just membrane samples, membrane coupons. We lose a lot of information. Just having a look to the full element, we can have a very valuable information about, for example, some problems with the pretreatment, as on this membrane showing a high amount of carbon, anthracite probably, how these particles can go in between some membrane envelopes and damage the membrane after, spacer protrusion related to some high dP issues, for example. And also during the internal inspection, even not going to sophisticated analytical techniques, it's possible to detect some issues on the membrane. In some cases, that high amount of filtration material reaching the membrane may produce preferential channels and to accumulate on certain envelopes, polyamide delamination. I don't know if you see my mouse, how I'm showing it, but it's something that when it's very significant, we can observe just visually. And of course, the presence of foulant. And also during this internal inspection is where we take samples. And it's one of the critical steps on the autopsy, to choose the right sample to get the more representative information from the membrane. We can see here on the full element how there is a different color, for example, at the rejection side than on the feed side. This inspection, in some cases, just gives information about different kind of foulants at the feed and at the end. So this part is really important and critical, as I said. And then after sampling, we, of course, have to make different analytical techniques and tests. And we use different tools depending on the needs and the objective of the study. We always carry out systematic analysis, but it's important also to have a feedback from customers and from the people working in the plant to know about the objective of the study, because then we can focus more on specific issues as damage, for example, or the composition of foulant, etc. There are many different tests and analysis and analytical techniques available, but there are two main tools that we use for studying foulant, which are, for example, scanning electron microscopy. This is basic for us. It's like to have a look on the membrane. We just magnify and start seeing how the foulant is distributed or how it may affect the membrane. We have included here some examples. On this white and black photograph, we can see how a foulant looks, the most common mixture of organic with colloidal matter, for example, or we can have a look also on this colored photograph about how the foulant and the different components of foulant, which are colored different here, are distributed on membrane surface, or if they have an impact on the membrane surface, causing some damage. By this way, by this scanning electron microscopy, we can identify the foulant components to see how it is distributed, but it's an elementary analytical technique, so we need to use additional analysis to really verify how the elements that we detect here are related, which will be, for example, this infrared spectroscopy, which spectra I'm showing here, that give information about functional groups, and some database can be used to really identify the composition of the foulant components. In this case, I included an example of an organic foulant, which is biofilm actually, but this technique also allows to check chemical integrity of the polyamide damage. So these are tools that certainly allow to study both the composition of foulant, which is necessary for cleaning tests, etc., and also the integrity of the membrane. And what is more important, to know how those failures or the presence of foulant affects the parameters, the performance parameters of the membrane. So during autopsies, it is necessary to check also both flux and salt rejection, which will give an idea about how the issues that we are detecting before are affecting the performance of the membrane, which at the end is what we really need to know. Here we are including an example of some membranes giving a lower flux than expected. That will be related to a foulant, for example. And in any case, always based on these parameters, we carry out cleaning tests, which are the tools to check if the membrane performance can be recovered or not. So here I have included a graph of different tests done in one of our autopsies where we check different cleaners. And we check, for example, in this case, the increase in flux. And considering the highest, we say, okay, this cleaner is the best. And then we have to optimize the cleaning procedure by applying different steps, different contact times, different pHs to really get the best way to remove the foulant and to be able to verify if it's possible to recover the membrane performance. And that's basically what an autopsy is. We cannot go in detail to many more analytical techniques, etc. But if anyone has any question or that, they may contact me, and I'll be happy to share more information.
Thank you, Doctor. I have a question I'll just put the question on the screen. So what about external inspection of scaling in the membrane? What do you do on the external inspection?
External inspection of scaling. Scaling is produced into the membrane, okay? It is true that in some cases, during the external inspection, it is possible to detect the scaling, imagine on the reject side of the membrane, sometimes on the external housing, which will be related to different tissues. But the external inspection, when there is a scaling, it doesn't give much information. It is necessary to open it and to take samples and to analyze, unless the membrane is very heavy. Scaled membranes, when there is a massive scaling, will weigh a lot more than the reference weight of the membrane. That with that information, you could say my membrane is scaled. If it's 40 kilograms, for sure you have a scaling. That would be the main information with no need to open a membrane to know if it's scaled or not.
Another question, thank you, Dr. Nuria. Another question from my friend Bart. So he's asking for if you measure the SAC-254 and for organic fouling, and also if you do specific autopsy due to chlorine, do you test any chlorine damage?
We don't measure that UV, that measurement about UV, we don't measure it on organic fouling. Something that it's commonly measured in water, but not for organic fouling. We really look for identifying, to really know how much there is about an organic component. For example, consider that the foulant is a solid, so we commonly make loss of ignition or thermogravimetrical analysis, which are based on the temperature degradation of certain components to determine organic component as a global concept. but not its measurement at 254 nanometers. And of course, we make also autopsies to determine if the problem is chlorine or not. We didn't have time to show it, but there are specific tools and tests to check if the membrane were in contact with halogens. Fujiwara test is a very traditional test, but also XPS or ISCA could even distinguish if the oxidant agent is chlorine, bromine, or other component. During autopsies, it's something quite common to check if chlorine is the cause of the failure.
Thank you, Nuria. I have a question from my side. Like, how long typically it takes from the day you receive a membrane to the full autopsy? On average, how long it takes? How many days, process-wise?
It depends on the objective of the autopsy. To have an identification of foulant will be in 2 weeks, for example. To have a full autopsy, checking integrity, cleaning tests, etc., it commonly takes 4 weeks. Okay? It depends also on the hurry. We always try to adapt to the needs of the customer. If there is a real hurry, a real problem, in some cases there is a very important meeting, we try to adapt our delivery time to that. But if not, it takes time because you need certain information before you make cleaning tests.
Okay, and it's an interesting question coming from Juan Pablo. So I know you guys do a lot of also product development, so this question is right on time. So do you use the information you identify to develop better chemistries?
Yeah, sure. Actually, it's the way to have it. And we always check for example, the cleaners we develop during autopsies. When, at least in our company, when we start selling chemicals or cleaners, we have tested already on real foulants. And to use this information, of course, because from all this data, we already have some statistics about which is the most common foulant, which is the most common mixture of foulant components, etc. So yeah, for sure, data from autopsies are a very good tool to develop cleaning procedures, cleaners, etc.
Excellent. Thank you, Doctor. I think we're running out of time. I'd like to thank you and also Walt for joining us today. I'll be posting the videos online and we can all see them later. So thanks for everyone who has joined also.
Thank you.
Have a great day.